Okay, so we've got this question. Theta is here, phi is there. We're going to solve both angles. Okay? Right, if I want to solve theta first, which trig ratio do I use?
Sine.
Sine. Opposite and hypotenuse, okay, so sine theta is equal to O over H, and sine theta is equal to 30 divided by 30 root 2. So, what does that simplify to be?
1 on 2, root 2.
1 on root 2, right? Because 30s will cancel.
You wrote 2.
I wasn't finished yet. Okay, 30s cancel. And now 1 on root 2, you guys need to be comfortable.
Is it 1 on 2?
It is 1 on root 2. Now, you need to be comfortable with converting this to a answer that has no a denominator without a circle.
Okay.
So if I multiplied this by 1, can you see that that's 1?
Mm-hmm.
What's root 2 times root 2?
Root 2. Oh, it was like...
A third and a square root
oh,
and
so
a
it'd just be
square
2, that's right,
cancels,
yeah.
right? So it's just a 2. And 1 times root 2 is root 2. Okay? So 1 on root 2 is the same as root 2 on 2. Okay. Now we're ready to take the sine inverse.
Sorry, question. Would 1 on root 3 be the same as root 3 on 3?
Yes, very good.
Hey.
Good generalization. And what is the sine inverse of root 2 on 2? 45 degrees. Okay, so that's another one you're going to have to memorize.
Is it so
I
45
thought it was
degrees?
60, 45 and 30. What's 30?
The sine of 30 is 1/2.
Okay, so we just need 60, 30 and 45.
That's it. Those are the ones you have to know.
Wait, so
30,
which
60,
ones?
45.
Okay.
Well, we'll do a summary in a minute. Okay, so if this is 90, that's 45, then this must be
45.
45. Now, let's use our trigonometry to validate that. If I have this side and this side,
Cosine.
then I'm going to use cosine. Very good, Levi. So cosine phi is equal to the adjacent divided by the hypotenuse. The adjacent is 30, and the hypotenuse is 30 root 2.
Oh, so it's going to end up being...
Same working out, isn't it?
It's cosine, so it's different, isn't it?
That's right. So cosine phi is equal to root 2 on 2. When you take the inverse, I'm going to get 45 degrees.
Oh, the inverse, and didn't take the inverse.
Yes.
Wouldn't it be the same if you just left it without doing the root 2 over 2? Just the 1 over
Yes.
root 2?
Yeah, they're the same. They are the same. So if you took the sine inverse of that or the cosine inverse of that, you will get the same answer as if you did it this way. They are equal to each other.
But what's the benefit of converting it? Isn't that just an extra step then?
It's a mathematical convention to write denominators without certs. Okay, kind of like how if I had an answer that said negative 3x plus 5, it's conventional to say the rule is 5, take away 3x, so that the first term is a negative. It's one of those conventions. Okay, so we would say if you have a cert in the denominator, it's proper to rationalize it. Okay.
Yeah.
And we'll pause there. That's good.
No, just